Burn the bots.
So I'm going to talk a little bit about the technology that's going to bring about the singularity and destroy all of mankind. And I think we have a ways to go, and so while we're getting there, we don't want to destroy the planet, and so that's what this talk is about. In the true Swedish spirit, I have ripped all of the pictures and supporting material off the net. None of it's annotated here. None of the numbers I'm throwing out are made up, and if you actually want the supporting stuff, you can ask me later. But I'm going to talk about the cloud, the advent of cloud computing, and what that means for the future of carbon and IT. So I have a bit of a dual existence, as Walter said. I spend a lot of my time running this, which is a ridiculous thing. It's the world's largest marketplace for yachts, private jets, $2 million Bugatti Veyrons. We have 250,000 people a month that are on here finding the best possible deals on really amazing things. And I only started it because I'm a contrarian, so in the middle of the crisis, I figured, what's the most insane thing you can possibly do? And that was this, and it's worked a little too well, and I'm a little bit ashamed of the fact that it's working so incredibly well, but what it's doing is it's tapping into the fact that people are incredibly deal-oriented in all aspects of their lives, and luxury is no exception. The other half of my time, I run things like this. This is Post-Adjust, which is a brand new site that we're launching in the next couple of weeks. That's a community for people working in the field who, when you move, like I did, from Stockholm to Geneva, or a friend of mine who's working on this moved from Stockholm to Dakar, you end up in a 3-month kind of vacuum of trying to find a place to live, a place to put your kids in school, places to eat, all kind of mundane daily stuff that takes away from the true mission of you being there if you're working as a diplomat or in the NGO world. And so this site is a closed community for that group to work together. The reason I'm mentioning these is that these two sites I started, they drive a lot of traffic and they need computing power. A couple of years ago, or when I first started my first sites, I put them in my basement on servers, which I don't think was a particularly good idea given the environment down there. When things matured a little bit, we put them in nice aseptic data centers like this, which are still the norm. Most of the computing that you guys do, most of the websites you visit are in places like this. Most of the big corporations have huge data centers underneath them. Our sites, and many more of them, are in the cloud. And the cloud is a little bit of an existential problem to understand sometimes. So I'm going to run through it very quickly, and I'm going to use a cloud that you guys are very familiar with, and that's Google. The way that Google builds their cloud of computers, this is one of the Google servers that your searches are answered by. It's a very innovative little machine. It's very, very standard off-the-shelf stuff, and they've tweaked it nicely. They take these, and they stack them into stacks and hire guys like this in ponytails to hook them all together. They then take those stacks and stack them into containers. Right? And they stack those containers on top of each other and stack them into buildings like this. This is an actual Google, all these are actual images of Google data centers. And then they stack those buildings across the world. And Google's a pretty secretive place in a lot of ways. And so this is the best guess as to all the current Google operating centers or the data centers around the world. Now, the interesting part with this, once you have all of this amazing infrastructure, all these little machines that are all networked together and all these data centers that are networked together, is that you hook them up. And what you do in the cloud world is that you make them behave as one giant, not one giant server, but just computing capacity. So instead of thinking of them as individual machines, you think of them as utility. And the way that we treat them, let's say when I start a site, we start a server. I hit a button, I get a web server, or a database server, any other kind of server. And that server doesn't physically exist anywhere. It's a set of capacity that's there. I treat it as a server. I can think of it as a server, I can log into it, you guys visit it, but it's spread out all over the place. Now, I have an 8-year-old son who's unfortunately transitioning from asking me why all the time to saying so. So this is wonderful, and it poses all kind of interesting existential issues as to where is my server actually? What are we actually visiting? How do we actually handle it? Well, the SO is pretty interesting. There are lots of great SOs here. I'm going to focus on one that has to do with energy. Now, if you think of a server that's sitting there idling and doing nothing, you would expect it to expend no energy, because the energy involved in computing is expended as you try to solve a problem. And so as I go up to using it completely, I should use 100% of the potential energy that this server uses. In reality, when we look at, I don't know if that line is visible to you guys, but in reality, this is a benchmark of 7,000 servers over 6 months. A server that's doing almost nothing, let's say 10%, it's being used about 10%, is using more than 55% of its energy, potential energy. Now, that's a big deal, because if you look at servers generally, the thousands of them, hundreds of thousands of them around the world, they're not doing much of anything most of the time. They're dimensioned so that when you really, really need them, they can answer. But most of the time, they're sitting there. This is 5,000 servers over 6 months benchmarked. And what the graph is showing you is that more than half of the time, servers are only working between 30 and 50% of their capacity. All right? So most of the servers around the world are not doing much of anything at all. And if you remember a little bit earlier, they're really being energy inefficient. So if I have 3 websites or 3 applications running on 3 different servers, and they're only using 30% of the capacity, I'm only using a little less than 1 machine's capacity. But the thing is, I'm using almost 2 machines' power, which is a reasonably inefficient way to work. And what the cloud lets me do instead is to put those 3 machines into the cloud and only use as much capacity as needed. And that also then only uses as much computing power as needed, and you can be as efficient as we possibly can. Now, this isn't a new concept. The Navy's been doing this for a long time. On a submarine, you have around 120 guys, and they work in 3 shifts. They actually work 18-hour days, or they have 18-hour days. They work 6 hours and have 12 hours off. There's only one of those 3 crews that sleeps at any one time. So they have a wonderful practice called hot bunking. And I wonder if you guys can figure out why it's called hot bunking. But there's really only enough room, especially for the lower ranked guys. They share bunks. Leads to all kinds of interesting uses of socks and other things that we won't get into today. Besides being much more energy efficient for the actual server computing power, there are other really big reasons why the cloud is great from an energy perspective. So in a data center, the actual powering of the servers is usually only around half or a little more than half of the energy expended. And the rest is pretty much spent cooling these things. Anybody who has sat with a laptop on a Lufthansa flight on your lap, you know how hot those things can get. And keeping these servers cool is a really, really, really big deal. There's ways to measure this. I'm not going to go through all these numbers, but the consensus is coming around a measure called PUE, which is that 1.8 here. This is an average data center. An average data center has servers that use about 150 watts. They have a PUE of 1.8, which means that for every watt of computing power that's spent on the server, you have 8 watts that's spent doing other stuff like cooling it. We can then calculate, based on the power source, the amount of carbon that this particular server in this data center expends. So the cloud is nice from an energy perspective, because in moving into the cloud, we can use less servers. We can consolidate down. And less servers means we use less power for absolutely everything. It means that the setup is a lot cheaper to run, of course, and there's a lot less carbon emitted. Another so. This seems like an esoteric thing, so what, great, data centers are operating in a cloud, Google searches are fast and not expending that much carbon, but this is a really, really big deal. Data centers in the world stand for about 1.5 to 2% of global energy consumption. A typical data center expends as much power as 25,000 households, and these numbers are growing really fast. In the year between 2000 and 2005, data center energy usage doubled in the US, and it's on track to quadruple in the next 10 years. This industry is now actually emitting more carbon than the aviation sector, and everybody's all over there flying, but nobody's paying attention to this side of things. It's currently exempted from most cap and trade systems. It won't be in the future. And so we really have to start paying attention to the carbon that we're emitting. one of the paradoxes of the cloud is that the cloud is a lot more carbon efficient, but it's also a lot cheaper. I have 12 servers running for jameslist.com somewhere in the cloud. I couldn't afford that as a startup if I didn't have that infrastructure. So I'm using a lot more capacity to do a lot more things. And so even if the cloud is more efficient, we're going to use more power. This is a big deal. This is a graph of Amazon's cloud. Amazon has a wonderful setup where they have somewhere around the range of 40,000 servers linked together, and I can run my websites and applications on them. This is a graph of servers, instances that are launched. So it shows that today we're hitting about 50,000 new servers a day being launched in that infrastructure. That's a big number. Those spikes that you see are kind of fun. One of the big upsides of cloud computing is that you can increase your usage or your capacity as usage of your setup increases. So this is when a company called Animoto launched a Facebook app. Animoto is this wonderful Facebook app that mashes together your pictures as videos, and that's a very computing-intensive task. They launched and got tremendous kind of viral spread on Facebook. They went from 5 servers one day to 15,000 servers the next, and they could do that in this cloud, and that's what those peaks are. And they couldn't, of course, done that, and they couldn't have gone out and bought 15,000 servers overnight, but the cloud let them scale. The nice thing about the cloud, from my perspective here, is that they measure absolutely everything. Amazon measures absolutely everything because that's how they charge me. They measure exactly what I use. I'll get to that in a sec, but they also measure what comes in. And the reason they measure the energy coming in is that now a server's cost is outstripped by the cost of energy over the server's lifetime. So I'm going to spend more money powering it than actually buying it before that server dies. This is my bill for last month for JamesList. They measure exactly how much capacity I'm using, how much storage I'm using, what I'm moving, which in what way, and then they come up with a nice little total at the end of it. And then there's a button, and I'm not kidding you. I use the same credit card to buy books for my kids as I do to pay for my servers. And that button's there all alone today. Now, Amazon knows exactly what I've used, and they know exactly where the energy comes from to power those servers that I've been using. So I want that button, right? And I want that button to go somewhere specific. We all know now that the brunt of the climate change burden, and that is already on its way and has been created by all these emissions, will hit the developing world. Those countries that are least able to adapt will be the ones that are hardest hit. You have countries, or 10 of the 15 largest cities in the developing world are built in low-lying areas, cities like Cairo. Those are the cities that will be most hit by flooding and other disasters. The Netherlands spends, I think, $100 a year per person on flood protection. That's a quarter of the annual GDP in Bangladesh per person. You have cities like Nairobi, which were built right above the malaria line, where mosquitoes couldn't survive. And with pending climate change, it's calculated about 90 million more people in Africa will be susceptible to malaria. And they thought they were safe. Now, there are lots of things on the way to help developing countries cope. I think the most important is to foster an environment where indigenous solutions will help. And I think Nicholas talked about this morning. The One Laptop Per Child program and education for children generally, and leapfrogging in education generally, is one of the only ways we're really going to stem the climate change issues in developing countries. The OLPC XO is wonderful in lots of ways. It's also a very, very efficient little machine. So we know exactly what it uses when it's on, and we know that it's a lot more efficient than handing out proper desktop PCs to kids in developing countries to learn on. We know that even if you power it off of coal, it's a very efficient little thing. And so we should be able to count how many XOs I need to buy to offset my server usage, right? And that's what I want to do. And if we do that, what we'll be doing is empowering the next generation of engineers, public servants, programmers, and others to meet the challenges that we're causing. And we'll be doing so by creating a direct link between the computing power that I'm using and the opportunities that computing power is giving me, with giving computing power and opportunities to children that will create this next generation of solutions. So thanks.